recording? I even wrote this before class so that I would remember to remind you that assignment 1 is due tonight at midnight, right, or 11:59, but you know what I mean. All right, and so make sure you do assignment 1, it's on Moodle, okay? From here on out, they'll be due every Tuesday night, right, and they should, does it show you when they're due on Moodle? Yeah, okay, good. I know in the past there's been cases where I've posted stuff and it didn't actually, for some reason it didn't say when it was due, so it lapsed, but hopefully that's not a thing. Okay, so make sure you do assignment 1 because it's due tonight. And remember, I won't open it back up. Once it's gone forever. Okay, let's do just a tiny bit of review. Last day, what did we do? I think we talked about, well, we talked about solving systems of equations. What did we talk about before then? I can't even remember. Oh yeah, thank you. Thank you. We talked about expanding and factoring, which I think you might get a little bit of practice with in that assignment. And we talked about solving systems of equations. First by substitution, right? We had 2 methods, whichever one you choose is great. First by substitution. And then by elimination. I like solving by substitution because then I don't have to be clever or anything. I can just stick to the same procedure every time, right? I solve for one variable, I plug it in, solve for the other variable, and then I can easily solve for the first one properly. Okay. And so we won't do any questions of those because I think you have some in your assignment for today. Okay. So, any questions about last week or even the assignment if you've kind of come across some troubles? No? All right. Then let's do 1.6. It's just a quick little section on ratios, proportions, and percentages. Yeah. Sure. Oh. This one? Yeah. So it'll say something like here, just so you guys can see, 8198 slash, which is divided by, yeah, you're right, 1 plus 19 divided by 2 times 0.02622. Is that the one? Okay. So here, this is dividing. Okay. Same there. But also here, when we just have brackets and then a number, this is multiplication. And so if we just solve this one together, right, and you'll have had, this was from the Moodle quiz, right? Yeah, you'll have had something similar, different numbers, right, but the same procedure. And so if you're going through and doing this, right, BEDMAS says, okay, brackets first. And so what we're gonna have is we're gonna leave 8198 divided by And then inside our brackets, we have another set of brackets that we're going to simplify first. Okay. And so we leave everything else the same. And I'm just going to do 19 divided by 2, 9.5 times, oh, I should not put that bracket on, 0.02622. Now, the 9.5 inside brackets, we don't do anything inside the brackets because it's just one number, but it is showing that we're multiplying it by the 0.02622. Right, and so next inside our brackets, we have to do the multiplication before we can do the addition. Right, and so we get 8198 divided by 1 plus, oops, 1 plus times 0.02622, 0.24909. Oops. And then we get 8198. And then I'm just going to write it like this just to make it clear, over 24909. And then we get 6,563.177994. And you can just, there's probably instructions for how to round it, but that should be the number. No worries. Any others from you had trouble with? Great. Okay. Now 1.6, which is basically just going to be a quick review of kind of proportions, percentages. There's ratios in the title, but I don't really care about ratios. Okay, so 1.6 is called ratios, proportions, and percentages. Oh. Right. Okay. So we're working with money, right? A big part of money is interest, which is usually in percentages, right? Or always in percentages. Taxes are percentages, right? And so we should be pretty comfortable with percentages especially, right? But we're just gonna solidify those, and then we'll be using them a lot throughout the rest of the term, right? And so this is just a little sneak peek, and we'll kind of parking lot it for a little bit, and then we'll come back to it. Okay. The main thing, right, percentages are usually given as, 12% tax or that kind of thing, like a whole number. But to use a percentage in math, so in calculations, we have to convert it to a decimal first, okay? And so to be able to use percentages in calculations, we need to use the decimal form. Oops, decimal. Right. So that is 12% is 0.12, right? Or I should show you the middle step just once here, right? We just divide by 100, 12 divided by 100. .12. I shouldn't have, well, I guess that's fine. Okay. Yeah. Oh yeah, totally. Darn. I know sometimes, oh, I don't know. There's only two options. Is that too dark? Or else I can't. Can you guys see? Yeah. Or else like, yeah, little moles. Holy moly. Screen looks great though. Now it can really capture your attention. Okay, so right, so that's the main thing that you have to keep track of when you're working with percentages, is that we're gonna always convert it to a decimal first, right? And so something like 7%, right? 7 divided by 100, 0.07. Careful with your zeros, right? Or if you're going the other way, or 0.007 in percent, you'd have to multiply by 100, right? So 0.007 times 100 is 0.70%, right? And so those zeros make a difference. Okay. Right. Okay. Good. We also want to talk about, so when we express a percentage as a decimal, what we're really saying is we're using a proportion. And so a proportion is a fraction often written in decimal form and takes on values between 0 and 1. Okay. 0, right? If you think about 0, that'd be 0%. 1 would be 100%, right? If you multiply it by 100, right? And so 70%, 0.7, right? So we have to be kind of flexible, moving back and forth between percentages and proportions. Okay. So a proportion is a percentage divided by 100. And thus a percentage is a proportion times 100, right? If you move the 100 over. Okay. So let's have a look at a quick example. And what I'm going to do is I've just kind of screenshotted. No, I actually took a picture of the textbook. And then I'm going to steal those in here. But this is from page 27. And so the reason I do this is because I don't want to spend half the class writing out these blurbs. Okay, but if you just make a note to yourself that this is from page 27, then you can have that there too. Okay. So I like this one because it's really kind of fun to think about, right? So suppose there are 2 goods required to make a good sandwich. Good. Peanut butter and bread and jam. No jam. We know that it takes 4 spoonfuls of peanut butter to cover 3 slices of bread, right? So for every 4 spoonfuls, we can cover 3 slices of bread, right? So the ratio of peanut butter to bread is 4:3. Suppose that we have 75 slices of bread. Now we want to know how many spoonfuls of peanut butter are we going to need, right? And so what we have, right, is we've got essentially peanut butter to bread. Instead of writing it as a ratio 4:3, I'm going to write it as a fraction instead. Right? So peanut butter to bread, that ratio, we can rewrite in terms of numbers as 4:3, right? 4 spoonfuls to 3 slices of bread. Okay. So now, keeping things the same, right? If I know I have 75 slices of bread, I can fairly easily solve for the number of spoonfuls that I need, right? And so if I had given you this problem and let you work on it by yourself, there's lots of ways that you would have arrived at the right answer, and that's good, right? If you're able to get to an answer your own way, that's great, right? I'm just showing you one of the ways that you could set it up and do it. Okay? And so, and if you're ever unsure, right, if you're working through something and you're not sure if you're doing it kind of math legally, then ask me and we can have a look. But I'm sure most of the time it's a-okay. So now, if we want to solve for x, right, we've got 4/3, kind of ignoring this PB over B, that's just kind of a starting point, right? And so we've got 4/3 has to be the same ratio, right, as x over 75. So what we can do is we can say, okay, well, 4/3 times 75 has to equal x. Right? It's dividing on the right-hand side. To move it over, we have to multiply it over. If it helps, you could rewrite 75 as a fraction, right? Because you're just multiplying fractions. That's fine, right? You don't have to, it's optional. But sometimes it helps to see it that way. And then remember, I like to move my x over to the left-hand side as soon as I can, right? That's not, you don't have to, but I just prefer it. Let's see, I've got 4 times 75. I've got x is 300 divided by 3. So x would have to be 100, right? And so, like I said, if you arrived at that some other way, right, just by kind of reasoning and logic, that's fine, yeah.
I was going to say the way that we used to do questions like this would be like taking 75 and dividing it by 3, and then you get 25 and times that by 400.
Yeah, I can do that. Totally. Yeah, so whichever way comes naturally is good. And if no way came naturally to you, then this way's good. All right? Okay. But I always find that the less you try to memorize and the more that you just kind of do your own way, the better you'll know it. Okay? If we do example 52 from the textbook, and again, I've got this, we'll just steal this. Oops. So last time I ate out, my bill was $45 before 7% tax and a 15% tip on the bill after tax, right? So that's going to make a difference. How much did my night out cost me? All right. Kind of a typical scenario. I think we've all been there, right? We have to figure out how much something is with tax, and then we have to tip on top of that, right? We do that all the time. And so again, if you're able to kind of figure this out, that's great. But I assure you, at some level, we're going to be doing the same thing, right? Mine's just going to be more math focused, right? Or heavily math focused. So what we've got is, what I'm going to do is I'm going to figure out the cost before the tip and then the cost after the tip. Okay? So the cost before tip is the price of the meal plus the tax. Right. And so the tax was 7%. Just make a note of that. Okay. And we said, okay, well, the price of the meal was $45. I have to pay that. But then I also have to pay 7% of $45 in taxes, right? And so what I've got here is I've got 45 times 0.07, right? 7% is 7 over 100, which is 0.07. Okay. Notice here that I've got a common multiple of 45, right? The core tax, or sorry, the core price. And so what we can do is we can pull out that common $45, and don't forget about the 1, right? So now we're factoring out $45 like we were doing last day, and we're saying, okay, well, that can be rewritten as 45 times 1 plus 0.07. Which is going to be, well, just adding a step here, 45 times the 1.07. You don't have to show that step if you don't want to. Okay. Which 45 times 1.07, I get a nice 2-decimal 48.15 answer. So after tax, my bill is $48.15. Okay. I don't know about you guys, but whenever, like even when I was pretty young, if I had to figure out how much something was with tax, I would just multiply it by 1.12, right? If there's a 12% tax, right? And so that's what you're doing here. You're just saying, okay, well, the whole one is the actual price, and then the 0.12 is 12% tax that I'm adding on there, right? And so when you're figuring out how much something is with tax, right, really you can just skip to this step here and say, well, it's the core price times 1 point and then however much the tax is, right? And mathematically, this is why, right? But usually we just end up skipping straight to here and then there, right? Let's figure out the cost after tip. The tip is just another percentage that we're adding on, right? Oh, made a little triangle. I guess this app they came up with, like, now if you hold your pen for too long, it makes a shape of whatever you drew. And so I guess my P looks like a triangle. I don't know. So the cost after the tip is going to be, I'll use words first, I guess. The cost before the tip, which is what we just found, plus the tip. Right. And the tip is going to be 15%, I think it was. Yeah. Wait. 15%. And so we've got 48.15 plus 48.15 times 0.15. Same idea, right? The exact same idea. And even if you wanted to skip that step now and just go straight to 48.15 times 1 plus 0.15, or even further, skip straight to here, 48.15 times 1.15. Oops. That's fine. So now 48.15 times 1.15 is 55.3725. In money though, right, we can only have 2 decimal places, so rounding properly we get 37 cents. So I'll throw the dollar sign on there, 55.37. Any questions about that one? Yeah. Let's do a similar one, but it's kind of in reverse, I guess. So I find it a little bit trickier, but it is the same idea. So example 53 says a local pub has offered a $10 dinner, right? And so that's the price that you pay, right? $10, and it includes 9% tax and a 15% tip, which is put on after the tax, right? And that matters, the order matters. What is the cost of the dinner to the pub, right? So how much are they actually charging for this dinner? But they're just charging you $10, but what would be the equivalent, right? If they were just advertising and then forcing you to pay 9% in tax and a 15% tip on top to get to $10, right? Which is the exact same thing that we did earlier, just in reverse. Right? And so we've got the total cost. The total cost is the price before tax Sorry, there's 2 steps, right? Because first I have to undo the tip, and then I have to undo the tax, right? Because order matters. So it's the price before, not the tax, but the tip. Plus the tip. If we let this be P, right, the price before the tip, before the tip or after tax, which do you prefer? They're the same, right? After tax, but before the tip, they're the same. Ooh. So it's going to be P plus the tip, which we know from the exercise that we did earlier we can rewrite as P times 1.15. Because the tip is on the price before the tip. Okay. The total cost is $10. If we solve for P, we can rewrite this as P is 10 divided by 1.15. 10 divided by 1.15, P is 8.6956522174. In money, though, we get $8.70. P is the price before the tip, which is also the price after tax. Yeah.
Why did you multiply P with because explain your
Oh, I skipped some steps. Do you mean between here and here?
Yeah.
Yeah? Right. See. Because what we did before, right, we said, okay, well, we've got the price before the tip, right? And then we're putting the tip, but the tip is the price before the tip times the tip percentage, right? And so I skipped some steps here, mostly because what would happen is we get, so the tip, right, the tip is P times 0.15, right? It's the price before the tip times 0.15. And so here, I'll squeeze it in. It's going to be 10 is P times 1 plus 0.15. Does that make more sense? So I skipped a few steps. Mostly because I think, I don't know about you, like, do you use this? Do you use times 0.15 or 0.12 or whatever? If you're in a store, something's $29.99, you just go times 1.12 to figure out how much it is? Or is it a surprise when you get to the cash register? Surprise! Anyways, so that's what I do. I just multiply things by 1.12. Or what is our tax here? I think it's 1.12, right? 12% still? Okay. It's 13% in Quebec. Did you know that? I think it's 13. Anyways, maybe it's a surprise to me too when I get to the cash register. Anyways, so I skipped a few things in there, right? Because I got that P and it's not really a value yet, right? It's just a variable. Okay. But now, better? Yeah. All right. What should we call, okay, so we've got the price after tax by the same setup is the price before tax plus the tax. Okay. Now I have to think of a clever, I don't know, all I can think of is P, right? I can't use P because that was here, the price after tax, we used P, right? Price before tax, B for before, I don't know. There's not a very good variable. And then plus the tax, which is going to be b times, what was it, 9%? Yeah, 0.09. Okay. So what I'm going to do right away, because I'm going to try to solve for b, the price before tax, right? I want to have as few b's as possible to solve for, and so that's why I'm going to factor them out and say, okay, well, p is b times 1 plus 0.09. Now I'm showing the steps I should have shown earlier. P is b times 1.09. P from earlier we know is 870. Is b times 109. Solving for b, we get 870 divided by 1.09. Oops. 8.7 divided by 1.09. B is 7.9816511376. So B in money is $7.98. The cost of the meal before taxes and tip is $7.98. Right. So the restaurant could either average or advertise, hey, come have this meal, this hamburger for $7.98, right? Or, I don't know, for me it sounds a little bit better to have, hey, for $10 you get this burger and it includes your taxes and your tip. You don't have to think about it, right? But to the restaurant, it's the same deal, right? Any questions about that one? Okay. So, like I said, percentages, taxes, they're gonna stay steady throughout the course, right? So we're gonna be dealing with taxes and interest and all that fun stuff. But for now, we're gonna just get into some linear functions. So we talked about solving systems of equations last day, right? And so we're gonna go back to those a little bit, just equations of straight lines, how to graph them, right? Because later on, next day, we'll start by graphing equations and maximizing our profit. And that sounds pretty good, right? So linear programming. All right. So we're into chapter 2. 2.1 is on linear functions and graphing. We talked about straight lines last day, but in general, we have an equation of a straight line. Looks like, typically we use y equals mx plus b, right? In high school, that's the most common thing. But really, whatever is attached to the x is the slope, and whatever is on its own is the intercept, the y-intercept, but we won't really talk about the x-intercept. Okay. So m, right, is the slope. Whatever value is attached to x is the slope. And b is the, I'll say y-intercept here just to be clear. Whatever value is on its own is on its own. Oh. Hey, it turned my value into a straight line. It couldn't make a better shape. Man. Value is on its own. Okay. Remember, the y-intercept is where the line, so you've got a straight line somewhere, and the y-intercept is the value of y where it crosses the y-axis, right? And so essentially where x is 0. Okay. So this is where the line crosses the y-axis. Oops, crosses. Which means that x is 0. And if you think about if x is 0, right? So by definition, the y-intercept is the value of y when x is 0. And if you make x equal to 0 here, this term goes away, and then you just have y equals the intercept. And so that's what it's telling you. Right? So, okay. Right. So I'll keep using y equals mx plus b, but some other formats of y equals mx plus b would be something like y is ax plus b. Y is a0 x plus a1. That was pretty common. Or in stats, we would use b0x plus b1. Or even b1x plus b0. As long as you remember that whatever term is on the x, that's the slope. And whatever term is on its own, that's the intercept. That's all you need to remember. Okay? It doesn't matter the format. Notice here that we've got our two variables, right? A y and an x, which is the exact same scenario that we had when we were solving those systems of equations, right? We've got just an x value and a y value. Right? So, whenever we have an equation with just the y and an x as the variables, we can rearrange it into the form of y equals mx plus b, right? It might take a little bit of work, right? But we can rearrange it into that notation. So whenever we have an equation with just, oops, with just y and x as variables, we can rearrange it into the form y equals mx plus b. So what we're going to do is we're going to start by graphing straight lines, right? I'm pretty sure you guys have drawn straight lines before, but I'll just walk you through the general rules. So we only need to know 2 points on a graph in order to draw a straight line, right? Because a straight line just goes on and on forever. But as long as we know 2 points wherever they are, however close or however far apart, right? As long as we can plot 2 points, then we can take a straight edge, right? Edge of your book, for example, connect those dots, and then we just draw the line, right? And so that's what we're going to be doing. And because one of the things you have to come out of this course knowing is how to draw a straight line on a graph. That's pretty important. So how do we draw, or how do we graph straight lines? Okay. Given a linear equation is just y equals mx plus b, or something that can be arranged into y equals mx plus b. Let's say something simple like y equals 2x plus 1. To draw y equals 2x plus 1 on a graph, we first need to find 2 points that are on this line. Okay? And so we need to find 2 points on this line, then use a straight edge to connect them. How do you find 2 points? So essentially what you do is you force x to be some value, right? If x is 0, what is y, right? That's usually the easiest point to find, right? And what I like to do is I just like to make a table of these values, right? When x is 0, y is this. When x is 1, y is this, right? You can keep going and collect more points, but what you'll find is that they're all on the same line, so it doesn't really matter. Okay? But the first thing you're going to do is make a table of at least 2 values of x. Your second step is to find that corresponding y value. So find the corresponding y value. I guess values. So now you've got x, y coordinates, right, which we also call ordered pairs. that you can plot on your graph. Okay? And so plot the xy, which we write x comma y inside round brackets. Okay? Plot the xy coordinates, which we also call ordered pairs, on a graph. And last thing, connect the points and extend the line. Connect the points and extend the line. For example, if we have to draw y equals 2x plus 1, okay, first thing I'm going to do is I'm going to make the table, right? Pick convenient values of x to solve for y, right? And you'll see what I mean by convenient later on when things get a little bit trickier. But so what I start by doing is my first step is I'm going to say, okay, well, x and then y on the other side, and I like to have the full equation for y up there. Right. And then you can pick any two values of x, right? Since we're drawing these and I haven't given you a grid, right, to use, we're going to make our own grid for this, but on a test, I'll give you the grid. I'd probably pick values of x that are on the grid, right? But otherwise, it's really hard to plot them. But besides that, anything goes. So I always do x is 0 unless it's completely unreasonable, because it's really easy to solve for, right? So then y is 2 times 0 plus 1, which is just 0 plus 1, which is 1. And if you just wrote 1, that's fine. Okay. Picking any other value of x, I'm going to choose 1. That's easy to deal with, right? I can still do that math kind of in my head. And so 1 is y equals 2 times 1 plus 1, which is 2 plus 1, which is 3. Okay. I'll just make a little note here. Pick, I'll put in quotes, convenient values of x. And people tend to have a hard time with that part because there's no rules for which ones you're going to pick, right? But as you do more practice, you'll know what's convenient, right? X equals 0 is usually convenient. X equals 1 is usually convenient, unless they're really tight together when you're drawing them, right? That makes it difficult. Then maybe x equals 10 is a better option, for example. Okay. And so over here, we've got our ordered pairs. When x is 0, y is 1. And when x is 1, y is 3. Now, you don't have to have, the stuff I wrote in green is kind of optional on the side, right? But that's how we're going to find these points on the graph. And so because I'm drawing my own axes, right, I have to figure out what values of x I need. Right here, I only looked at x equals 0 and x equals 1. So maybe a little bit more than that, but not too much more. And let's see what I can do here. And my y's went to from 1 to 3. So as long as I can fit 1 to 3 in there, I'm okay. So on the y-axis, I've got 1, 2, 3. And on the x-axis, I've got 1, 2, 3. Sure. Yeah. So to draw this line, right, y equals 2x plus 1, I have to first plot these ordered pairs on here. And so I've got, color code them, 0. So when x is 0, y is 1. That's here, right? When x is 0, y is 1, that's that point. And so I do expect you to be able to find points on a graph. And that's also the y-intercept, right? 1. My next point, when x is 1, y is 3. And so I'm here at 1 and then 3. Now for the tricky part, I have to draw a straight line connecting these two, right? But what I'm gonna do is, well, this may not be long enough here, but right, what I do is I take any straight edge, and as long as I connect these and draw the line and extend it, that is y equals 2x plus 1, right? For all those values of x. You only need 2 points, but it's true for all values of x. Okay. Now my iPad usually glitches a little bit when I try to do this. Hey, not bad. Got the touch. So here, this is the line y equals 2x plus 1. Yeah. Any questions about that? Okay. All right. What if we do one that's a little bit trickier? Oh, page breaks, so I'll start here. What if we do example 54, sketch the graph of 4x plus 5y equals 2. Okay. This is not in the form of y equals mx plus b, which is kind of what we like to see, right? But we can rearrange it, solve for y, and then we have y equals mx plus b. So let's do that first. So solve for y to get this into the form y equals mx plus b. So if we start at 4x plus 5y equals 2, we get a little bit of practice solving for y here, right? And so we have to move everything over except for the y, holding the y steady. So the first thing we're going to do is 5y is 2 minus 4x. Then y, to solve for y, we have to divide both sides by 5. So we get y is 2 minus 4x divided by 5. Or we write y equals 2 over 5 minus 4x over 5. We're allowed to split this up, right, as long as we take care to keep them both over 5. Right? And so as long as we remember that they're both divided by 5, we are allowed to split them up, right? Because if we were just faced with this, to combine them, right, we'd have to make sure that we have this common denominator, which we do, and then we would smush them together and make this term, right? So we can move back and forth. That's allowed. Okay. So this is not as pretty as the 2x plus 1, right? But it wasn't meant to last. So now we have to deal with these trickier ones, right? But the procedure stays the same. We're going to find 2 points on this line, right? And here we're going to pick convenient points of x again. Right? And so find 2 points on the line. I'll set up that table again. X on one side, y on the other. Y, I'm just reminding myself, is 2 over 5 minus 4x over 5. I'll always use x equals 0. It's the easiest thing to deal with. And so when x is 0, I get y is 2 over 5 minus 4 times 0 over 5, which is 2 over 5, which is 0.4. Let me just check. Yeah. Okay. So in terms of an ordered pair here, when x is 0, y is 0.4. We could draw that point right away, but I'll find the second point first. So now it's time to pick a convenient value of x, right? That's not 0. You could use 1, right? But if you use 1, then you have to deal with these fractions again, which is fine, right? 5's a nice one, right? Because then you can cancel one of them at least, right? And so exactly, so I'm going to use 5 just to show you that you don't always have to use 0 and 1, even though they're usually pretty convenient. Y is 2 over 5 minus 4 times 5 over 5. Okay. That 5 over 5 is going to cancel, which makes 0.4 minus 4, which is negative 3.6. So in terms of our pair here, we've got 5 and negative 3.6. Okay. Let's think about what this graph is going to look like, right? Even what we expect it to look like just by the equation. So if we go here, remember whatever is attached to the x is our slope, right? And so here we've got a negative slope, which means we're going to have something going in this direction, right? And so where it crosses the y-axis is going to be the highest point, unless we're looking at negative x's, which we won't. And so our intercept is actually going to be the highest value of y, and then they're going to be decreasing, right? And so we have to make room for x from 0 to at least 5, right? 6 might be nice, just have a little bit of wiggle room, right? Because we use values of 0 and 5, so we have to have room for those at least on our x-axis. And then on our y-axis, we have to have room from at least 0.4 to negative 3.6, but we'll put little buffers on just in case, all right? Be cool, okay? Are we locked in? Oh. So when we're drawing our graph, okay, let's see if I can fit this all on. Because I've got a page break coming up, I'll just write my little note here. So we know we will have a negative slope okay. So that means that we'll have something that looks like this, right, going downwards. This is a negative slope. And if we have something that looks like this is a positive slope. And so depending on if the value attached to the x is positive or negative, right, that tells us which direction our slope is going to go, right, or our line is going to go. Okay. So if we have to draw these here, try my best to do an x and a y axis that are going to work here. Yeah, tell those guys. So here I've got x is 1, and then I'm going to do -1, -2, -3. I'll extend it down -4, and of course it keeps going. But remember, we just need all the way down to -3.6 for our purposes. A little bit more is nice. Okay. And then we said we need x from 0 to 5 at least, but 6 is nice, right? And so 1, 2, 3, 4, 5, 6. Okay, nice. Of course, because I'm drawing this by hand, it's not going to be perfect, right? But close enough. And so that's why on the test, when you have to draw lines, I'll give you the graph that you have to draw it on, right? So it'll have the little axes on there. Okay. But it's just good practice to know what you're doing. Okay. And so our points that we're plotting here, the first point is 0 and 0.4. Right? And so we're going to have 0 when x is 0, y is 0.4. Kind of put it there almost halfway through. And so we've got 0.4. And our second point is when x is 5, y is -3.6. So x is 5, just tracing down from 5 to -3.6. I don't know, I'll just put it here somewhere. Without a grid, it's really hard to know where it's going to be exactly, right? But we're just practicing drawing lines anyways. And so here we're at 5, -3.6. Now all we have to do is connect these dots, extend the line, and then we've drawn the line of y equals 2/5 minus 4/5x. So again, just use your straight edge and connect those two dots. Draw the line. Nice. Usually in like a test scenario, you've got the page. You can usually just kind of, I don't know, fold it however you need to and use that as your straight edge. So you don't have to bring a ruler or anything. You can just MacGyver it. Okay. So this is the line y equals 2/5 minus 4/5x. Okay. It's always a good idea to write at one of the ends of the lines what the equation of that line is. Okay, because later on we're going to be graphing multiple lines on one graph, and so you want to keep track of which one's which. Right? And so that's why I just put the equation at the end of each line. Cool. Any questions about drawing straight lines? Who knew it was so complicated? It's not. But when you have to break it down and talk about how to do it, it becomes kind of complicated. All right, so then let's move on to talking just about functions. And so a lot of what we're doing here is we're just developing terminology so that we can just be clever in the next few chapters. And so let's talk about functions. A function is just when we can give it some value of x and it returns some value of y, right? Y equals mx plus b, we put in some value of x and we get some value of y, right? That's a function. So takes a value of x and returns an output value of y or f of x. Okay. I want you to read f bracket x bracket as f of x. Okay. So it's just saying that f of x, you put in some value of x and it'll give you some output value. Okay. One thing to keep in mind and kind of makes it easier to deal with, y is f of x, right? To get y, we plugged in some value of x and then we were able to solve for y. So y is a function of x. Okay. So y equals f of x, and we were just dealing with the function mx plus b. Okay. Y and f of x in this course, right, and for most courses, are interchangeable. As y requires a value of x in order to be solved. So starting simple again, if f of x is 2x plus 1, find f of 2, right? What this is saying is it's saying solve f of x when x equals 2. Right? And so that's usually how we denote it. And so we've got f of x is 2x plus 1. F of 2, just replacing all my x's with 2, I get 2 times 2 plus 1, which is 4 plus 1, which is 5. Okay. Oh yeah, sorry. Okay. Since f of x is 2x plus 1 is in a straight line form, right? It's a linear equation. So we know that we can have something like, and we know we have a positive slope So when we plug in x equal to 2 into 2x plus 1, what it's saying is that, okay, well, this x equal 2 maps back to f of x equals 5, right? Or y equals 5. Yeah. Any questions about that one? Yeah. If we do example 57, let f of x be just 3x plus 1, just for some more practice. Find f of 10, oops, and f of negative 5. Starting with f of 10, right, we've got 3 times 10 plus 1, which is 30 plus 1, which is 31. And then I'll solve for the next one right beside it, just so I don't have to scroll up so much. F of negative 5, again, just plugging in 3 and then negative 5 for x. I get negative 15 plus 1, negative 14. Sorry. More relevant to this course, right? What if we have a profit function? So we'll be dealing with profit functions in a little bit. And so example 60 kind of gives us a sneak preview. If we let the profit of x be 45x minus 725, and x is the number of hours worked, part A, what if we work 50 hours? So what is the profit if x is 50? What is the profit when x is 50? So we've got our profit function. So our profit of x in general is 45x minus 725. So we've got 45 times 50 minus 725. 2250 minus 725. 1525. So if we work for 50 hours, we would have a profit of 1,525. And that's taking into account all our fixed costs, right, as well as our wage. Oh. How many hours would you have to work to earn 0 profit? Okay. So how many hours must you work to earn $0 in profit? Okay. So essentially what this question is asking, okay, how many hours do you have to work until you start making money, right? Because any hours after that is when you start making money, right? But your first few hours, and we'll figure out how many right here, those are just paying off your costs, right? Your rent, your phone bill, whatever, right? And so we've got the profit of X is 45X minus 725. If we force the profit to be 0, we can solve for X, right? The number of hours. So now we have to solve for X, so we have to move our 725 over. So we've got 725 is 45X. Now I'm doing that switcheroo where I put my X on the other side. X is 725 divided by 45. And I get 725 divided by 45. X is 16.11111, repeating. So it's not until I've worked 16.1111 hours, right? More like 17 hours if we're being realistic, right? Unless you can bill for 15 minutes or whatever, right? But if you're working on whole hours, it's not until you've worked 17 hours that you actually start making money, right? Otherwise, you're at a negative profit. And what we'll see later on is that a negative profit is actually, it's sometimes better, right? You still keep working because you're still paying off your bills, right? How many hours must you work to earn $1,000 in profit? This is essentially the same question as the one we just did, right? But instead of X equals, or profit equals 0, right? Now we're forcing the profit to be 1,000, but it's the same scenario. Right, so again, we're saying, okay, well, if profit of X is 45X minus 725, and I'm forcing the profit to be 1,000, then I can solve for X. So again, I'm going to add 725 to both sides, and so I get 1725 is 45X. X is 1725 divided by 45. Oops. X is 38.33 PD. Okay. Any questions about that one? All right. So you might remember talking about the domain and range of a function in high school, maybe, I don't know. But let's just do a quick recap. We're not really going to use them, but let's talk about the domain just because it brings up some illegal math. Like we can't divide by 0. We can't take the square root of a negative number, right? Those are some key things to remember. But we can't really talk about functions without talking about the domain and range. So here we go. The domain, oops, let's start with the domain just on its own. The domain of a function is all possible values of X. If a value of X results in division by 0, or the second no-no is the square root of a negative, that value of x is not in the domain. Okay. So here, because dividing by 0 or trying to take the square root of a negative number, that's an imaginary number, so it exists, but it's imaginary, right? The square root of -1. But these result in illegal math. Right? And so if you get a value of x that's going to force you into doing something like that, it's not in the domain. Right? The range of a function, my pen keeps glitching out. I don't know why. Like that. Ugh. Is just all possible output values, right? All possible values of y. The range of a function is all possible values of y. Right. Or all possible output values. Could call them as well, but they're the same. Struggle city here. Yeah, my pen looks like valves. Ha. Yeah. So the domain and range, it's just good to know, right? Especially for other courses. Let's just do one last quick example. Just end on a high note, then we'll be done. How about? So, example 63. Given a formula like this, or a function like this, fv is pv times 1 plus I to the power of n, where fv is the future value, and we'll deal with equations like this quite a bit, but not until after test 1. So where fv is a future value, pv is the present value. I is the yearly interest rate. What we'll find is that later on these definitions are going to change a little bit, but for this example, this is what they're going to be. And n is the number of years. So now I'm going to give you a scenario where I give you, so right, there's 4 unknowns. So I'm going to give you 3 of those, and you have to solve for the 4th one. Right? And so if an investor invests $1,500, that's the initial investment, making that the PV. right? The present value, right? So the present value is always the initial investment. I'll add that up here. So if an investor invests $1,500 at a rate of 6%, right? That means that I is 0.06, right? Because we always have to convert our percentages to decimals, right? To proportions. What is the value of the investment after 7 years? Meaning N is going to be 7. Basically, it's asking you to find PV. Sorry, FV. Yikes. Slip of the wrist. There. Okay. So we've got the future value. We were given the formula is the present value times 1 plus I to the power of N. As long as we do our bed mass properly, right, should be pretty safe because we've got all these values. So we've got 1,500 for our present value times 1 plus 0.06 to the power of 7. We've got brackets, so we have to deal with our brackets first, and then we deal with that exponent to the power of 7. And so we get 1,500 times 1.06 to the power of 7. Only the 1.06 is to the power of 7 though, right? And so we get, if we do 1.06 to the power of 7, remember you use the y to the x button? So you have 1.06 on your screen and then hit the y to the x button, 7. Equals, and we get 1,500 times 1.503630259. Keeping all those decimal places, whether you just keep it on your screen, right, and then multiply it by 1,500, or even if you store it, that's great too. But if you multiply this by 1,500, you get 2,255. I'm going to write out all my decimals, but then because we're dealing with money, I'm going to round to 2 decimal places, 0.445388, which in money is $2,255.45. Whew. How's that for a high note? With time to spare too. I know I don't give you a break, but I do end early, so pretty good trade-off. Any questions? All right, so I'll see you guys on Thursday. Make sure you do assignment 1.
When assignment 2 you do?
Next Tuesday at midnight. Yeah.
I just want to solve this question.
Sure. Let me just end this here. Let's see. See you later, Brett.